Hello. So now we're moving on to our next unit packet, Unit 11, which ties into Section 6.1 in our book. We're going to look at what's called the standard normal distribution. We'll leave the applications to Unit 12, so we're just going to focus on how we're going to work with some key aspects of the standard normal distribution. But before we get to the standard normal distribution, first let's talk about, I know this may seem confusing, we're first going to talk about the normal distribution. So the normal distribution, it's a distribution that has a continuous bell shape for some random variable x. As you can see, the graph it has that bell shape, and some of the main properties of this normal distribution is that the mean is at the center of the distribution. So for any normal distribution, the mean, which is represented by the Greek letter mu, is always at the center of the distribution. Also, it turns out that the median is at the center of the distribution because half of the data lies to the left, the other half lies to the right. Also, it's the mode. The mode is the data value that has the highest frequency. The highest frequency occurs at the peak. So the mean, median, and mode are all located at the center of the distribution. The graph is symmetric, meaning that if you were to cut it down this line here, it's symmetric about the mean. You would have two equal pieces. And even though it looks as if the graph touches the x-axis at the edges, it doesn't. It gets very close to the x-axis, but never crosses it or touches it. Finally, what's going to be important to us is that the area is just the amount of space. So the area under the curve is always equal to 1. And what that means is that half the area to the left and the other half of the area to the right, they're equal to 0.5 each. Okay, let's move forward. Okay, so there's a very important rule that we want to be aware of. It's called the empirical rule, and I was able to obtain this information from Pasadena City College. The rule just says this. It kind of breaks down our areas really nicely for us. We say that if we were to add and subtract the standard deviation to the mean, we say that that's one standard deviation from the mean. What that tells us is that most of our data will fall within that region. So 68% of our data falls within that region. Now, within two standard deviations of the mean, that's 95% of our data falls within that region. And finally, once we hit 3 standard deviations from the mean, all that's telling us is you add 3 standard deviations to get one side, subtract 3 standard deviations for the other side, and that entire region that's encompassed will be almost all of your data will fall within that region. So 99.7% of the data falls in that region. Okay, now we're going to get back to the standard normal distribution because that's going to be the main tool we're going to use to find areas under the curve. That's going to be our goal in this section, is to be able to find different areas. So one way is to use, if we know the standard deviations, we can use this empirical rule, but it's going to get a little bit more complicated because some of the problems will not fall nicely within these parameters. So thus we have to be aware of what's called the standard normal distribution. Well, the standard normal distribution is a special case of the normal distribution. Here the mean is equal to 0 and the standard deviation is equal to 1 always. If you see mean equal to 0, standard deviation equal to 1, that is the standard normal distribution. Also, this axis is not an x-axis, it's called a z-axis. So whenever you're working with z values, that tells you that we are working with the standard normal distribution. Now, what's nice about the standard normal distribution is we have a table that we can use to look up the areas under the curve. So let me just show you what the table looks like. So the table, and I do have a copy of the table for you guys to examine. So this is the table. We're going to be working with this table to find areas under the curve. So it has 2 pages. It's table E. So the first page deals with negative z-values. So you find the areas for negative z-values. The second page deals with positive z-values. And if you remember the empirical rule, just to really, because I want to highlight something here. So if you recall, the empirical rule tells us that at the extreme values, the areas diminish. So let's look down here. So if you're looking up a z-value that's less than negative 3.49, you're just going to say that the area is 0.0001. And on the opposite side, if you have a z-value that's greater than 3.49, you're just going to say the entire area is 0.999. So just to tell you also how this area works, or the table works with the areas, it's always working from left to right. So your area is always going to be from left to right. So let's look at some examples now of how to use this table. So our first rule says the following. Rule 1. To find the area under to the left of any z-value, all you have to do is you look up the z-value in the table and write down the area. So let's work on an example here. I have 2 examples for us to try. The first one says find the area to the left of negative 1.23. So what we do is we look up the z-value on the first page of our table. So we're going to look up negative 1.23 in our table. So let's do that. So you always look up the first 2 digits. So it's negative 1.2. That's going to be right here. I'll try to highlight that. See? Oops. So negative 1.2, and then we look for 3. Well, 3 is over here. So negative 1.23 gives us this area of 0.1093. And that's the area that I have written there. So that tells us that this little shaded red area is equal to 0.1093. Now for the second example, it's a positive z-value. So it says look up the z-value in the first. In this case, we have to go to the second page, not the first page, because all the positive z-values are on the second page. So you go to the second page. Let's go down here. This is where the positive z-values are. And we're going to look up 2.04. So once again, we focus on the first column. 2.0 is right here. And then we go to 4. So you go across all the way until you're under 4. And so that's going to be 0.9793. And that's how we get that answer there. Okay, and then I have another example for people to follow. Okay, and then there's some examples for people to follow here. So remember, just to recap, to find the area to the left of any z-value, just look up that value in the table and write the area down. That's pretty simple. Now our second rule is to find the area to the right of any z-value. So now instead of just looking up our area to the left, we want to look up an area to the right. Well, all you do is you still look up the area to the left. See, let's look at this example. So you look this area up to the left, but remember the entire area is equal to 1. So what you do is you subtract that area from 1, and this red area is what's left over. So for the second rule, let's just read through it. You look up your z-value in table E, you write down the area, and you subtract the area from 1, and that's going to give us the area to the right. So let's look at our examples here. So first, we want to find the area to the right of any z-value. So I just want to highlight some notation here. So sometimes I'll write it out, find the area to the right of any z-value. Sometimes I'll use mathematical notation. Z is greater than negative 0.56. That means the area to the right. So we look up negative 0.56. Let's look it up. Negative 0.5. So here's 0.5 down here, and you go across to your under 6 at the top. See, at the very top is 6. So negative 0.56 is 0.2877. So that's going to be this white area, 0.2877. And then we subtract that from 1, and we get our answer, which is this red shaded area, 0.7123. So this red shaded area is 0.7123. Let's look up the area to the right of 1.65. So once again, it's a positive z-value. So we go to the positive z-values now, 1.65. So we locate 1.6 and we go all the way under 5. That's 0.9505. Right? We take 1 minus 0.9505 to get 0.0495. That's this area to the right. Okay. And then there's some examples for people to try. Finally, we have our third rule. There's only 3 rules. That's the beauty of this section. Here we need to find the area between any two z-values. So we're going to look up both z-values in the table and write down both areas. However, we always subtract the smaller area from the larger area. So, and I just want to highlight some notation here. Whenever we're looking to find between negative 2.45 and 1.09, you can just say that it can be written using this notation here in math. Even though it looks a little confusing, the way you would just read this notation is that z is between negative 2.45 and 1.09. Okay, so let's work out these two examples. We want to find the area between 1.8 and 3.9. So remember, our first step is we go back to our tables. We're going to look up both areas. So let's look up 1.8. That's 0.9649. And we also want to look up 3.9. Well, when you try to look up 3.9, it's not listed here. So that means we have to go to the bottom of our table. Anything above 3.49, which 3.9 is, will be have an area of 0.9999. So we have our two areas, 0.999, 0.9641, and remember, to get the area between them, subtract the larger, subtract smaller from larger. And so this area of the strip is 0.0358. Let's look at this example. We have a negative and a positive z-value. So this was an example of two positive z-values. So now we're going to go back to our table. We're going to look up negative 2.45. So negative 2.45, 0.0071, and we're going to look up 1.09. So we have to go to the positive section. 1.09, that's 0.8621. So we have our two areas, and remember, subtract smaller from larger, and our answer is 0.8550. That's the area of this strip. And there's some examples for you to try. Now the last part of this section is we're going to reverse our process. We have to find, instead of finding an area, we're going to be given an area, and we have to find the corresponding z-value. Okay, so there's a couple of problems in the back of the book of this section where you have to actually find the z-value. So I just want to run through the process. So the first step is you find the entire areas to the left of the z-value. Sometimes this requires adding a missing area or subtracting an extraneous area. The whole point is this, is you have to start from your z and fill in everything to the left of it. Okay, so if you so let's take a look. So we want to look up And then after we get that entire area, you're going to just go back to your table and you're going to look up that area or the area closest to it to find the missing z-value. So let's go through this. So the first step is you want to get the area to the left of the z-value for this example. It's an area between 0 and z, and it's 0.4370. So if we want this entire area to the left, you have to fill in this empty space here. That empty space is equal to 0.5, because remember, half the area is to the left of the mean. So now we combine these two areas, so 0.5 plus 0.4370, that's 0.9370. And then so now we're going to go back to our table, and we're going to look up, not on the outside, but on the inside for 0.9370. So yeah, it's ordered, but it's a little chaotic because there's so many numbers, but you have to search out 0.9370. And if you see, there it is right there, 0.9370. And so you look to the left, 1.5, and you look up 3. That tells us that the z-value should be 1.53. And I kind of pointed out here with this example. So the z-value that produces point must be 1.53. And then we have two examples. I'm just going to go ahead and work out the second one here. That one's an easier one to work on because if you notice, you don't have to add or subtract any areas here. They just tell you that they give you the area to the left of z, 0.0495. So all we have to do, and then keep in mind that since the z is to the left of 0, it's going to be a negative z-value. So we have to look up just 0.0495 on the first page of your table. So let's go to the negative z-values because it's on the left side of the mean. And we look for 0.0495. So let's see, 0.0495 is right here. 0.0495, and that's going to give us negative 1.65. So that's going to be our z-value for that second problem there. It's going to be, let's just write that down. So remember, this is the reverse method. There's a few problems that you have to be aware of. So it's negative 1.65. That is the z-value. And so we're done with the lecture for section 6.1. Take care and keep studying hard, folks.